Hey bro, so I was just thinking a little bit more about the encoder on the most important application, or the highest priority probably, the chop saw station here, and I had a few thoughts. So you can see the situation with the two solid blocks of aluminum bar stock that are 3/4 of an inch by, I think it's 2 1/4 above the table. All right, I don't know where my scale is, but oh, here's a tape measure. So yeah, 3/4 by 2 1/4, and the distance between them is essentially 1 1/4 inches. Go down here to the stops. To this one, I attached a piece of 5/8 diameter solid aluminum so that it reaches all the way to the cut, which is very nice. And the length of solid aluminum is precisely 20 inches, so that if you want to use this stop for greater capacity, this stop doesn't have the length of aluminum, and so you just merely add 20 inches to the indicated dimension on this, and that is the length of the part you're going to cut. So something to note about these things, which may sort of inform how we go about adapting them. When I loosen it, you can see that, watch that gap right there between the side of the Maya stop, or the jaw of the Maya stop, and this piece of aluminum. If I have it loose, it seems to tend to want to rock like this way. So you can see there's like a little bit of a bigger gap there. When I tighten it, that gap down at the bottom goes away, and the thing is just absolutely rock solid. Now when I move it, there is a little bit of a tendency to, it can rock, but another problem is that when you move it, like if I just naturally walk up to this and push it, it doesn't move. You almost have to kind of square it, put a little pressure on it this way, and then it slides really nicely. So because it's not automatic that it moves really perfectly, that often leads people, especially the uninitiated, to do crazy things that really, rocks it pretty violently. So what I'm wondering is if maybe I should adapt some little spring or pressure roller, like a little roller bearing on an arm that presses against this side, so that it constantly stays so that the face of the jaw is parallel to the this aluminum block at all times. And so maybe that would mean, if I always had a little bit of tension on it that way, that you could slide it back and forth really nicely without causing it to kind of freeze up and jam and rock and probably lose encoder ticks. Down here at the very bottom, there's about 15/16 in height, and of course the full 1 1/4 width that is always open or clear. And the aluminum on the bottom of this thing is super burly. It's like 3/4 inch solid aluminum. That dimension there is about 1 inch. So there's plenty of meat there where I could drill and tap for attachment of anything. I guess in this case maybe the encoder housing would be attached at 2 points here and here, which are about let's see. So if I line the side of that up to 90, it's like, they're like 3 1/4 center to center on those two things. So that seems like it should be plenty of space to mount the encoder. Now, what if the encoder, get this damn thing back on here. There we go. So I'm wondering if the encoder lived inside a piece of like rectangular, I guess, steel, because of the high magnetic permeability of steel. It would have a benefit shielding nearby magnetic fields. Not sure if we need it, but it doesn't hurt, certainly. So if we had the encoder that was housed on the, let's say, the top wall, or the bottom, yeah, the upper wall of a piece of steel rectangular extrusion, rectangular tube, and let's say the rectangular tube is, I guess, 3/4 of an inch by 1 inch or something like that, so it would easily fit in that 15/16 by 1 1/4 volume. And let's say that the encoder strip were mounted to some semi-rigid strip of material that hopefully has a very low coefficient of thermal expansion. And the encoder strip would, of course, run from one end to the other. It would just be attached, I suppose, at one point at this extreme end. And it would be attached at such a height that it would be sort of the natural, it would be at the same height as the height that the rectangular tube holds it in relation to the encoder. So, in other words, this thing would float, and I guess since the rectangular tube is basically supporting the weight of it, it would also have a tendency to keep this down. So between applying some pressure here with like roller bearings on both sides of the Maya stop, and the weight of the encoder strip mounted to some substrate material that would be kind of rigid, like a piece of rigid plastic or something, I guess. You have to look at thermal properties of these various materials. I wonder if those two factors combined would really eliminate almost any chance of misalignment. It seems like you could constrain the strip and its substrate at like both ends of this tube, and so even if you tried to do this, I can't see introducing any sort of error inside, you know, the confines of the housing where the where the strip lives. So that's that. That's the reading. As far as the power communication, I wonder if it could be something as simple as putting you know, dollhouse wire, one on this side, one on that side, or two on this side, one above, one below. And I can't think of anything else to say, and you're probably asleep by now anyhow, so that's the end of this video.